Good morning, friends. Today we have discussed about centrifugal compressor. So, see here, in previous lecture we have discussed uh, basic information of centrifugal compressor, introductions, parts of compressor, and classification. After that, we have discussed about detail of compressor, means parts of compressor, impeller, diffuser, like that. So today we have discussed about diffuser, types of diffuser, like that. So see here, diffuser in centrifugal compressor, the flow leaving the impeller passes through diffuser. The diffuser can be vanillary space, vane, or a combination of both. The function of the diffuser is to convert the exit kinetic energy into pressure. Diffuser being a static part, the total condition, pressure and temperature do not change across it, but the static pressure and temperature increase with consequent decrease in absolute velocity. In high stage, pressure rating compressor, sorry, in high test pressure ratio compressor, the diffuser reading edge region is crit- critical because the high Mach number giving rise to shock and shock, shock losses. So see this is diagram of the diffuser. We can see here, this is diffuser, this is I. We know we have discussed already in previous lecture. Character scroll when diffuser, shroud, impeller, hub, Wenrich diffuser, inducer section, direction of rotation. So character diffuser, see this is diffuser here, this is character, shroud, impeller and inlet. This is part of compressor. Types of diffuser. Vane diffuser, curve vane or divergent channel, aerofoil shape vane, uniform thickness curve vane, wedge shaped vane, uniform thickness stressed vane. We can see here types of diffuser, various types of diffuser. We can see so this is types of diffuser. After that, straight wedge shaped diffuser. So in the diagram, we can see a straight wedge shaped diffuser. See here, shape of the impeller like as a straight wedge. Of the diffuser. So see here, pipe diffuser. We can see here pipe diffuser. This is diagram of pipe diffuser. The diffuser, see, this is cross section of pipe diffuser. Impega vane paste, diffuser vanes. Different types of diffuser and geometries we can see here. Different types of diffusers and geometry. Radial impeller with diffuser vane. Types of impellers. See here. Types of impeller we can see here. One-sided, two-sided, shrouded, unshrouded, radial, backward swept vane, forward swept vane, types of impeller we can see in diagrammatic form or picture form. Back swept impeller, forward swept impeller, radial exit impeller, forward sweep. See here V theta radial exit V theta equal to U2 and backward sweep V theta greater than U2. Backward sweep impeller beta equal to or less than 90 degree. Forward sweep impeller beta 2 equal to or greater than 90 degree. Radial exit impeller beta 2 90 degree. This is schematic view of centrifugal compressor. Centrifugal compressor, three main types of impeller used in centrifugal compressor are open impeller. Open impeller is used in single stage compressor to produce high head with but small flow. Semi-open impeller. Semi-enclosed impeller is used in single stage compressor or in the first stage of multi-stage compressor to produce large flow. Enclosed impeller. The enclosed impeller is used in multi-stage compressor where pressure is increased is to high discharge pressure. Diagram of Walgut casing. Casing, impeller, inlet guide vanes, energy housing. When the impeller rotates at high speed, the suction is created at the impeller eye and the air is drawn in through the accelerating nozzle. Due to flow acceleration in compressor inlet part, the velocity of air increase from C0 to C1 and thus pressure and temperature decrease. This acceleration is not isentropic but accompanied with friction. Thus, P1 and T1 are the pressure and temperature at inlet of the impeller. Due to energy supplied on the compressor shaft, the impeller is rotated at speed of 20,000 to 30,000 RPM, and thus each particle of air passing through the impeller is accelerated. That is, the kinetic energy of fluid is increased. The impeller vanes are such that the cross-sectional area between two vanes increase from inlet to outlet of the impeller. Use rise to diffusion action Cr2 square minus Cr1 square by 2. Addition to this air enter the impeller at smaller diameter and come out larger diameter. This gives rise to centrifugal action U into 2 by 2 minus U1 square by 2. Thus, due to diffusion and centrifugal action, a part of Ke, kinetic energy imparted to the air, is converted into the static pressure and temperature rise. The absolute velocity, sorry, absolute velocity C2 of air at impeller outlet is very high, and it has to convert into pressure energy. This conversion is achieved in the Wengress and Van diffuser. The Wengress diffuser converts some part of kinetic energy into pressure energy, and velocity reduces from C2 to C3. The Wengress diffuser also stabilizes the flow coming out from impeller so that the entry to the vane diffuser is without shock. The rest of Ke is converted into pressure energy in the van diffuser and the velocity reduced from C3 to C4. The air leaving the van diffuser is collected in spiral passage from which it is discharged from the compressor. Pressure and velocity variation across centrifugal compressor. In this diagram, we can see a pressure and velocity variation in the centrifugal compressor. See, in the impeller, our velocity increased C1 to C2. In radial distance of clearance from C2 to C3, diffuser increase velocity. Pressure also increase up to P3. Above figure show that pressure and velocity variation across the centrifugal compressor. So air enters the compressor at means radius with low velocity C1 and atmospheric pressure P1. It is then accelerated to high velocity C2 and pressure P2 depending upon the centrifugal action of the impeller. The air now enters the centrifugal The air now enters the centrifugal. The, the air now enters the diffuser where its velocity is reduced to some value C3 and pressure increased to P3. So in practice, about half of the total pressure rise per stage is achieved in the impeller and the remaining half of the diffuser in the diffuser. A centrifugal compressor is dynamic displacement machine where the inertia force is applied to the gas transmitted by impeller, which by dynamic centrifugal force is applied to the gas transmitted by an impeller, which by dynamic centrifugal motion adds velocity energy through acceleration of the gas. This velocity energy is retarded in a vane or vaneless diffuser, transforming most of that velocity energy into additional static pressure. In the diffuser, the same as in the additional compressor component, like the inlet character, exit character, stationary vane to guide the flow. There are pressure losses, therefore the impeller has to produce enough energy to satisfy the pressure requirement plus those losses. Centrifugal compressor or blower consists of casing in which revolve one of the more impellers mounted on a shaft supported by one or more bearings. Gas enters the impeller near the shaft and is discharged at the outlet end of the impeller blade. When the shaft is rotated, the effect of centrifugal force upon the gas within the impeller causes its compression and at the same time induce is to is to is to flow through the impeller. The gas passing through the impeller is accelerated and the increase in velocity is from energy convertible into additional pressure. The conversion is produced by the gradual or orderly decretion of the gas either in a braided or open diffuser. A volute or scroll surrounding the impeller. Centrifugal compressor working. Impeller rotating with shaft and casing that enclose impeller. Fluid force into fluid force into inlet by upstream pressure fluid moves to discharge side as impeller rotates. This created varied this created wide or reduced pressure at impeller inlet. Pressure at compressor casing and inlet forces additional fluid into impeller to fill the void. After reaching the integral, create, creating, entering, move, move along the integral when increasing velocity as it progressive fluid at integral outlet tip is at max velocity. The fluid enters the casing where expansion of cross-sectional area occurs, diffusion process occurs. Fluid velocity decrease, pressure of the fluid increase. Process variable relationship in a centrifugal compressor, imperial speed equal to velocity, velocity increase, pressure increase, flow increase. This is static and total rate properties. In rotary compressor, high fluid velocity are encountered and therefore total rate quantities which take into account the kinetic energy have to be accelerated. Kinetic energy to be have considered. See, in rotary compressor, high fluid velocity are encountered and therefore total rate quantities which take into account the kinetic energy have to be considered. If the moving air is brought to rest isentropically without external work, transfer then resulting state is known as total head. Stagnation state and corresponding value of the properties describing this test are stagnation properties. See what is stagnation. If the moving air is brought to rest isentropically without external work transfer, then the resulting state is known as total head or stagnation state and corresponding value of the properties describing this state are called stagnation properties. Consider a horizontal passage of varying area with no external heat transfer and work transfer. Static and stagnation temperature. It is the actual temperature of the air that would be registered by thermometer moving with air with the same speed of air is called static temperature. If the moving air is brought to rest isentropically without external work transfer, then the kinetic energy of the air is converted in the of the air is converted into the heat energy increasing temperature of the air. The resulting temperature of the air is called stagnation temperature. As a steady flow energy equation for 1 kg of air flow diverging passage with no heat and work transfer is given by U1 plus P1 V1 plus C1 square U equal to U2 plus P2 V2 plus C2 square by 2. H1 plus C1 square by 2 equal to H2 plus C2 square by 2. specific heat H equal to CPT. So CPT1 where T0 is known as stagnation temperature T plus C square upon twice Cp. T plus C square upon twice Cp equal to T0, where T0 is known as stagnation press temperature. See here, T minus T0 equal to C square upon twice Cp. So T0 equal to T plus C square upon twice Cp, where T is static temperature and C square upon twice Cp is for dynamic temperature. So in next lecture, we have discussed about stagnation pressures. Today, we have stopped here. Any doubt, any queries, please ask me in stagnation process. Today, we have stopped here. Any doubt, any queries, please ask me. So today, we have stopped here in the meeting.